Hi, welcome back to EdQuest. In our previous video, we saw how we install the Kubeflow and its dependencies. In this session, we will do the Kubeflow Graphical User Interface walkthrough, which we installed in our previous video. If you have ever wondered how machine learning workflows are tracked, visualized, and managed at scale, this is where it comes together. From organization your experiments to scheduling regular retraining, the pipelines UI gives you full control and transparency over your machine learning lifecycle. So I am switching to the user interface of Kubeflow. Here you can see we pick the snippet and the pipeline list is available: experiments, run, recurring runs, artifacts, and executions. So let me go to the actual running Kubeflow user interface and then I will explain you. Okay, first of all I will explain the pipeline, and the same Kubeflow UI is running on a node machine which is running on IP 192.168.1.100 and port is 31380. We will walk through 6 key components: pipelines, experiments, runs, recurring runs, artifacts, and executions, and learn how each one fits into a real world ML workflow. Let's start with a quick overview. The Kubeflow pipeline UI is made up of 6 major elements: pipeline, your ML workflows; experiments, a way to group the related workflows; runs, actual executions of your pipelines; recurring runs, scheduled repeated executions; artifacts will give you your outputs and data; executions will help us behind the scenes steps. Now let's break each one down. Pipeline. A pipeline is a predefined sequence of ML tasks like data cleaning, model training, model evaluation, model versioning, and the model deployment. You write these using the Kubeflow Python SDK and compile them into YAML files that Kubeflow understands. Pipelines are important because they make your ML process reproducible, scalable, and automated. You will use a pipeline whenever you want to orchestrate a series of machine learning steps, for example, to train a model every time new data comes in. So these are the some available pipelines into the default environment. Coming to the experiments, this acts like a folder or namespace that groups multiple pipeline runs. Imagine you are testing 3 different models or 2 data pre-processing techniques. You had grouped those in one experiment so you can compare results cleanly. This is essential when you are exploring variations in hyperparameters, datasets, or the architectures. Next is runs. A run is one actual execution of a pipeline, either triggered manually or automatically. It logs everything: input, output, performance matrices, even errors. Runs help you to validate and debug your workflow. Want to see if your model performed better after a tweak? Just compare runs. Next is recurring runs. Recurring runs take things to the next level. They allow you to schedule pipeline runs at regular intervals. Want your model retrained every night or re-evaluate every Monday? Just set a recurring run. This is vital for production machine learning, especially for continuous retraining or monitoring pipeline. Coming to artifacts, artifacts are the tangible output from your pipeline steps, models, datasets, logs, and metrics. Kubeflow stores and versions them, so you can always trace what model was trained with which data and with what accuracy. Artifacts help with reproducibility, collaboration, and debugging. Next is execution. Behind every pipeline run are the actual executions. These represents the tasks being run in the background, usually as Kubernetes pods. You can drill down into each execution to see logs, resource usage, input and outputs. This helps in debugging and auditing, especially when a step fails or behaves unexpectedly. This was it about today's session. We will record another session where we will explain via the Python notebooks how we can execute the Kubeflow pipelines or how we can manage the experiments. Thank you.